Hi everyone, myself coming from AML department second year. Today we can solve one neural network problem, XOR problem by using neural networks concept of perceptron by using multi-layer perceptron. For that I am importing a lot of program sheets, etc. We can start step by step explanation of each and line cell programs. First of all, I import necessary packages as we everyone know NumPy matplotlib for data computation and data visualization. First, I will run it. Second, I am initializing input vector for XOR problems. I am creating input vectors by using np.array. Okay, I am creating inputs in the form of array. Okay, 2D array. Second, I am initializing the model parameters in the form of number of neurons in input layer, number of neurons in hidden layer, number of neurons output layer, and M is representing the training sample size. Okay, LR represents the learning rate. You should know that a learning rate for the model it cannot be or it should not be more or should not be less. Okay, it should be moderate to according to the model. Okay, let's execute the successfully executed and for as we know every neuron intake of product of input and weight plus bias gives the output. Okay, it's correct. So for that weight I'm generating two weights. Why I'm generating two weights? Because here you see that I'm giving or creating a two input x and y. Weight w1 give for weight for x and w2 is weight for y. Okay, so for that I create two weights randomly by using np. Okay, second and thirdly you can see a losses variable it contains empty array because I need to find loss at last because then only I can know how my model is performing, how much deviation is present in between the original output and what I'm predicting output. Okay, as As I know, I will create a model, number of parameters, importing packages, weights, etc. Next step for that model, we need some activation function. How much information our model should take. For that, I'm creating a function sigmoid by original execution rule. Our original sigmoid equation is 1 by 1 plus e power minus it is the equation. So I'm giving that equation. The such of minus z is a parameter. So I'm going to pass that parameter to the sigmoid function. So it will execute or it will find sigmoid for given inputs. Okay. Second, first of all, before I can execute, um, next cell containing a function named called forward underscore prop. Hmm. As I know, we are using the perceptron, but why am I here using forward underscore probe and back underscore prop? Because here I am using a back propagation. Basically, I can explain what is back propagation. Back propagation is nothing but there are two way of finding outputs. Two direction is achieved. Okay, you can like RNN, recurrent neural network. Okay, here a forward underscore prop is nothing but a passing of input from input layer, hidden layer, output layer, giving a output. Okay, this is forward underscore prop, and backward underscore prop is here output layer is acting as a input layer and input layer is acting as the output layer which provides some kind of outputs. This is a basic concept I'm using here. You can, I know you can see, understand the every line each and every because you can, I know you are studying. Okay. Here a main concept is here train the MLP. Still now we created a lot of model parameters and implemented here. To train MLP, I'm going to use what are the parameters I'm creating. Everyone I'm going to use it here. To use it here only, I created every parameters. Okay. First of all, you can see a function named train underscore MLP contain. There are six parameters. W1 to weights, to inputs, learning rate, iterations. Okay. These are the parameters I'm doing. Here, iteration is nothing but how many times a model can train. Okay. How many times a model can accept the input and retrain it by itself. Okay. And inside a function, I have a for loop in range of iteration. As you know that a for loop condition is actual. And you can see I'm passing a parameters for forward and etc. And I'm finding loss. You can see loss np dot mean value, and I'm giving that pass loss value to. Before that, I'm creating a loss variable with the empty array. Wait, I show it here. Um, you can see I'm saving the loss value to this array. For that, I'm giving this line and to I'm making the loss value to into the empty losses array. Okay. And the same as here, I'm passing a values to back propagation and I'm going to predict the value what I'm giving. I'm giving inputs value and testing values here and make prediction. Okay. Nothing. Second, I'm going to plot a loss value. As still I'm created plot underscore losses. I'm going to plot for losses here. You can see the loss function, loss value, and how many epochs you can see. At zero epoch, you see a loss value of 0.208, and keep on epoch going increasing. Here, loss value is decreasing very minutely, not at all less. 0.28 is maximum. The loss value came to 0.25. That much value, that much model is performed well. Okay. At last, I'm testing XR problem. You can see here, input value. I'm giving a sam. I'm testing it. I'm predicting or testing the model. Okay, giving. I'm randomly giving position 0, comma 1, 0, comma 1, 1, comma 0, 1, next one. I'm iterating some values into and if I bar loop, I'm making prediction, giving that inputs to the my model and make it prediction. You can see that I'm giving input 0 and 0, predict output 1. Why 1? Because say both are in the same place, there will be output 1. You know, Excel problem. That way you can understand what process is happening. Okay. Thank you everyone for watching my videos. And if you have any doubt, you can contact me for my email ID. Or if you have any project, you can contact me. I will show you my email ID. Yeah, you can contact to my email ID regarding any project or any teamwork, any hackathon. You can ask whatever you have doubts. I can solve it. Okay. Thank you for everyone.